Does that ever happen to you? The thing is, we hold a huge burden on the front end. My name is Nathan Walker, and I want to provide a purely introductory presentation on security. This is going to be from a JavaScript perspective, seen through the lens of NativeScript. I hope it'll provide some understanding to practices that can arm you for battle out there. JavaScript has several security considerations, most of which I'm sure you've probably heard of. They're all dependent upon the runtime context, and that's the cornerstone I'm going to focus on. These are things like XSS, CSP, secure cookies, and input sanitization. NativeScript, on the other hand, infuses the language of the web with the language of each device, whether that be Swift, Objective-C, Kotlin, or Java, wiping out this entire category of common security considerations in the traditional sense. The reason for this is the runtime context of your JavaScript, and the browser just has a generally wider surface area of vectors versus when it runs within the confines of an app installed on a device. However, this doesn't mean there are no security considerations when developing with NativeScript. To begin our journey, let's first look at a browser-based example. Now, this generates a key using the Web Crypto API, and we can also take, say, a JWT token and encrypt that token with the key. And this allows us to view the encrypted token and also decrypt it back. And we could also, say, for example, store it in IndexedDB. Now, this serves as a great example of why you would not want to do this. And that's because I can open the developer tools and I could introduce an XSS attack by injecting a script where I could simply grab the stored token and I could decrypt it as well. And now I can use that token to log in as you. With NativeScript, we can also provide this exact same behavior, even using the Web Crypto API as well. Generating the key, encrypting a JWT token with it. We could also decrypt it. And for example purposes here, we could store the token in a SQLite database. And of course, we could retrieve the token from there too. Now, although an XSS attack is impossible in this scenario, and that's because we can't tamper in developer tools and the view is rendered native to the device, meaning there's no DOM or remote scripting includes. For similar reasons from within the browser context, this NativeScript app would also be vulnerable to the same issue as IndexedDB. Say, for example, we plug our phone in, open Xcode, and choose the devices. We could find the app there and we could download the container for that app. This allows us to view the package contents and we could find that SQLite database file in there. And that would allow us to view it and grab the token there. And even if it's encrypted, this is not tamper-proof. So what we really need is a secure hardware-backed enclave accessible only via biometrics. An enclave is a protected execution environment isolated from the rest of the system, greatly reducing software-level risks. The web provides a JavaScript surface called the Web Authentication API, or WebAuthn for short, and it gives you a turnkey, origin-bound, hardware-backed enclave auth flow from within the browser context, which is excellent. But this talk isn't titled Authentication API Security. We need a bit more flexibility than even this. We need to store any arbitrary data securely in a hardware-backed enclave, not just tokens and credentials. Currently, there is no single standard web API designed for storing arbitrary data directly within a hardware-backed enclave. NativeScript, on the other hand, infuses all the raw building blocks with the JavaScript language itself. These are things like OS-level key stores, biometrics, cryptography with first-class platform guarantees. This ultimately strengthens our JavaScript with more security. The catch is you're responsible for wiring it correctly. So let's do that together. The goal of this talk is to give you peace of mind to know that when you're developing with NativeScript, you can do it securely. So as we dig deeper, it helps to have a good mental model of NativeScript. You could imagine yourself wearing JavaScript glasses, seeing your application in JavaScript, but yet also seeing all the native Android and Apple APIs with your JavaScript as well. It's fundamentally a more complete and illuminated world you're looking at from your base programming language. This also means you inherently have access to security standards provided by Apple and Android natively in your JavaScript. Consider this Kotlin code on the left and the Swift code on the right. Both use modern approaches to writing arbitrary data to a secure enclave. But here's what's neat. We could include these native source files directly in NativeScript, and we could call the function there, encrypt and store, from our TypeScript. Or we could even just write them in TypeScript. And that's pretty cool JavaScript security awesomeness backed by first-class platform protections. Now you might think, even though the method name is the same here, isn't that two different implementations for each platform in TypeScript? And you would definitely be correct. Now, you have this option, so you can do this, or luckily for your benefit, the community has consolidated them into a drop-in plugin named NativeScript Secure Storage, and it provides a singular JavaScript API to do this. So we'll use this to store what we're after, storing any arbitrary data securely. But just because our data is securely tucked away in an enclave and perhaps even protected behind user authentication, what if someone stole your phone, accessed your app while the auth was active, and they're now in your bank account? So this is, of course, one key element to the peace of mind we're after, but let's add the second one. Biometrics allow us to gate all these secure access points by, of course, either Touch ID or Face ID, and this greatly increases the security. And just like with Kotlin and Swift, we could also use this community plugin for biometrics, and we'll employ that here. Now we can surround all the secure storage access points with the biometric gate here. We'll enable it. We'll also enable secure storage here and run through the same example where we're generating a key. We're actually encrypting a JWT token with the key. But this time, instead of storing it in SQLite, we'll actually store it in the secure enclave. And it's backed by a biometric gate, so we could only view it if we have proper biometrics as well. The browser-based token example shown at the beginning, along with the NativeScript app utilizing these practices, can be found on my GitHub here. And we've made it. I hope you've gained some peace of mind when thinking about JavaScript security now that you're armed with NativeScript. Namaste.
So thanks a lot for this spooky talk. That was definitely an amazing intro. So yeah.
Spooky, I like that.
Thanks a lot. People are gonna have nightmares with all the security concerns now. No, but yeah, that was a nice introduction. Also, I heard about NativeScript like 7 years ago. So yeah, that went a long way. So that's quite cool to see. Maybe a few questions, Nathan. How do you audit the security of native API integrations?
That's a great question. I think the first surface level is the plugin usage. Plugin usage is going to show immediately what some common pitfalls are. Either you're going to go heavy in plugin usage or you're going to actually go straight to the platform. So the first line of auditing, I think, starts with the plugin usage and see if those plugins, number one, are using the latest practices. There's nothing wrong with using, plugins to do those things, but I think for sure, making sure those are using latest practices is the first gate. And then the second, I think, if you are doing kind of like the example that I showed there, the Swift and Kotlin example, if you're writing those in TypeScript, there are deprecation warnings that are actually in, for example, the iOS types that are in NativeScript. So you would see if there's something that is deprecated, and that's also a good line of auditing. If there's anything deprecated, you may want to go ahead and move those to the newer version. And then I think the third part of that is going through and looking at the docs, the platform docs. If there's Android recommendations that are better on any of those security tie-ins, I think it's good to try to move to any of the latest recommendations. Yeah.
Yeah, I think that people that have 200 packages in their package.json sometimes forget that it's also technical debt. It's not only, oh, you have something that works, you also need to maintain, check the security, to check if it's still up to the standards. So yeah, that's not as easy. I was just say, just use the thing.
So
Indeed.
some repo tools as well, automated auditing, that provides alerts on CVEs and various security audit practices like that is always good too. I mean, a lot of them can be very noisy. There will be things that will be flagged that may not be, applicable, but they're good to have an eye on.
I saw a new tab of a pen tester one day, and when he opened it, he had like a page fetching the latest 50 CVEs, and that was like a bit scary.
Yeah.
That's like a good practice to just check it every now and so yeah. Do we have any key security advantage of using NativeScript over regular JS APIs?
Yes. So that's one of the key things I want to highlight in that sort of brief lightning talk there is that because there is no standard web API for arbitrary data, that's the key thing. Like I often think of Apple Notes, for example. If you use the Notes app on your iPhone, those notes are being stored in an enclave backed. And so arbitrary data like that, there's really no standard way to do that on the web. The web authn is really for keys and credentials when you're doing authentication, and it does provide some biometric and hardware back stuff. But for arbitrary data, in mobile apps, you may want to store more data, deeper. And so when you can tie into things that are provided naturally, through iOS and Android, that allows you to tie into those secure enclaves in a much broader way. So yeah, it does offer more security in the JavaScript language through that. Yeah.
Okay. What about trade-offs between security and cross-platform compatibility? Because again, we don't have the enclave all the time. Like Linux has its own system to handle it, so I guess it's not easy.
Yeah, most, probably some trade-offs would be that you do sort of want to keep an eye on one or the other. So iOS and Android, because they both evolve at different paces, there can be security practices that may be recommended by Google and Android, maybe before Apple, and maybe sometimes Apple before Google. And so that's probably a trade-off, I think, in general with any cross-platform, especially keeping up with standards. There is trying to keep an eye on those and
even just
have a
Android,
sense.
depending on your version of Android, it's not always the latest, and each carrier has their own wrapper around it. Like the OS is not bare vanilla Android. So
Yeah, and like WebAuthn, I forget exactly what when that was introduced, but the common approach where you'd probably want to do some checks either against the browser, for certain features is similar with NativeScript. You may want to check an API level and know that that's only available, from API level 35 and beyond.
Okay. Perfect. Maybe as a closing word, I haven't seen any of the places where people could find you. Do you have any socials?
Yes. So on X, Twitter is www.alkerrun. That's like Walker Run.
Okay.
Also on Blue Sky at the same handle there. And those are two primary places, I'd say.
Okay. Then people will figure out how to ask you some expert security advice. Thanks a lot.
Oh, for sure. Thank you so much.